This is Heinrich. Heinrich is angry, because he's losing again at his favorite game. Maybe his input device is at fault. High system latency negatively affects performance in human-computer interaction. While humans are able to countervail latency to some degree, variations in latency are much harder to compensate. In order to improve end-to-end latency, measuring it with high precision and accuracy is necessary. However, directly measuring end-to-end latency confounds the contributions of many partial latencies. Therefore, in our research we focus on input latency, which is a small part of end-to-end latency. Furthermore, we narrow down only on its electrical and software components. To measure input latency, we developed LagBox. LagBox is based on a Raspberry Pi and allows for determining the latency of USB-connected input devices. To this end, it electrically triggers a button on an input device and measures how long it takes until the input event arrives at the application. Only an off-the-shelf optocoupler is required in terms of additional hardware. Input devices are opened for measurements, and test probes are attached to button contacts by soldering, with clamps, or pogo pins. For each measurement, the Raspberry Pi activates the optocoupler, which bypasses the prepared button. This is recognized as a button press by the input device's internal microcontroller, which in turn makes an input event available over USB. When the input event finally arrives at the application, the round-trip time is calculated. We call the time between electrically triggering the button and the USB event arriving at the application the device's input latency. This procedure is repeated automatically several times per second in order to collect a large amount of measurements with high accuracy and precision. Measuring and analyzing the latency of over 30 mice, keyboards and gamepads, we discovered some peculiar properties and differences between devices. Most importantly, devices not only exhibit differences in average latency, there is also great variety in their latency distributions. Our model of input latency helps to explain these findings. Input latency is affected by the input device's internal polling rate as well as the USB polling rate and internal delays. Depending on when an input occurs during a polling period, it may be processed immediately or a lot later. These factors lead to unique latency distributions. Therefore, reporting only the average latency of a device may be misleading. Forcing a 1 millisecond USB polling rate greatly improves latency for some devices. This raises Heinrich's capabilities to the next level.